The areas of chemical physics, and today I'm going to run through a few undergraduate level chemistry and physics questions, or chemistry questions I mean. So here's the first one. So we have copper ions in an aqueous solution that react with NH3 according to this equation. Giving us our copper, NH3, 2 plus aqueous, and the K, so the equilibrium constant for this is 6.3 times 10 to the 10. And then it wants us to calculate the solubility in grams per liter of copper bromide. So our copper bromide is going to dissolve and give us copper plus bromine ion. And the KSP for this is 6.3 times 10 to the minus 9. And so it wants us to calculate the solubility for copper bromide, given this K of solubility, but in a 0.64 molar NH3 solution. All right, so first, so what's going to happen here, right, is the copper bromide is going to separate, and then the copper ions are going to react with NH3 to give us copper ammonia. So if so the best thing to do to start is just to sum these reactions to get our total reaction, so if we sum these two, just add them up and put all the reactants on the reactant side. So there's our reactants, and they're going to react to give us our products. I'm going to just do it this way, and I should have put the aqueous in here. And plus copper ammonia. And now we can cancel anything that's on both sides, so we're going to get rid of the copper. And so our total reaction is just this. Okay, so now, awesome. So now we're going to want to get the K constant for this reaction, and so the K is just concentration of bromine, concentration of copper ammonia over our concentration of NH3 squared. Now if we look at our original reactions, this can be represented as the bromine, copper, copper plus times copper. Oops. I need to actually see the reactions. So we can represent it as our two reactions. So the first one I just wrote is actually the KSP, and then so that here would be our KSP, and this here would be our KF that we're given. Right, so if we multiply these two together, where this is now our KF, those coppers would cancel, and we'd get exactly our K, right? So that means that the K for our reaction, in our summed reaction, is just the product of our two Ks. So 6.3 times 10 to the minus 9 times 6.3 times 10 to the 10, which gives us 396.9. Okay, so now we have the K for our reaction. I'm just going to erase some of this stuff. So we have the K for our summed reaction, so now we can use that to find our equilibrium concentrations. I'm just going to rewrite our total reaction just so that I remember it also. So copper bromide solid plus 2NH3 aqueous goes to bromine aqueous plus copper ammonia. There's two of those and it was plus. Okay, so we're starting. Now, with our K constant, we can figure out our equilibrium concentrations given our initial concentrations. So this is solid, so we don't need to worry about it. This guy is in a 0.64 molar amount, and we're assuming at the beginning that these are all zero. Now that's our initial, our change. Representing our change just by x. So if we reduce this by minus 2x, I'm going to say, because there's for every 2 moles of ammonia, we convert to 1 of each of these. So our change is minus 2x, and we're gaining x here and here. And so that equilibrium, we're going to have 0.64 molar minus 2x, x, and x. And now from our K constant, which is concentration of bromine, concentration of copper ammonia, over our concentration of NH3 squared, we can fill in our equilibrium values. So that would be x, x, and I'm just going to drop the molar here for ease of reading, squared. Okay, so that's what our K equals. All right, and so we have 369.9 is equal to x squared over 0.64 minus 2x all squared. Now I forgot, or I made a slight mistake here, so I'm just going to rectify that by just doing a bit of this math on hand. So let's just do that. So 369.9 square root. So if we take the square root of both sides, because they're squared on top and bottom, then we have 19.233 is equal to x over 0.64 minus 2x. We can pull the denominator up, so that'll be times 0.64 times 0.64, and so we're going to end up with 12.309 minus 38.466x equals x. So just bringing that up, or 12.309 is equal to, so bringing this 38 over, 39.466x, or x is equal to this value divided by 39.466, which is 0.312. Okay, so that means our concentrations are 0.132, and now I'm just going to reappend the unit molar. Okay, so that's our concentration X. So now looking at the equation we've got, so that X is the concentration of our bromine, our copper ammonia, and our ammonia is some factor that depends on X, but that X is the concentration of both of these. So we're looking for our solubility, and now if we scroll up a little bit more, our solubility is going to be defined as the amount of moles of copper bromide that go into solution, but there's a 1-to-1 relationship with the bromine ion. So that means that however many moles of bromine we have in the end is the amount of moles of copper bromide that go into solution. So that means, looking at our equilibrium expression, that X is exactly equal to the amount of bromine, and so that X is also equal to the molar amount of our copper bromide. Okay, so that is our amount, but this is in moles per liter. We want it in grams per liter, so we need our molar mass of copper bromide, which is equal to M copper, the molar mass for copper, plus that for bromine, which is 63.546 plus 79.904. And so that's 143.45. And so our solubility in grams per liter is just 0.312 moles per liter times 143.45 grams per mole. And I should have realized that I also don't have this value, so I'm just going to do this again. 312 times 143.45. So our solubility in grams per liter is 44.76 grams per liter. Or, well, we have 0.64 molar NH3, so that would be our significant figures. So I would say about 45 grams per liter. Okay, so going through the solution here, so when copper bromide is added to solution. So we're going to sum the reactions. Our K is going to be product. We set up this ice table, which I showed as well. And we can equate to get a molar amount of our bromine of about 0.31. So that's pretty much exactly. 143.45. So I guess it's just that extra 2 there that gave mine a little bit of a nudge, but still it's about 44 point. That's curious, but anyway, about 45 grams per liter. So it looks like the solution's correct. There might have been a calculator error, but to me it looks like it's correct. I mean, it's about the same anyway. All right, so that looks good.